Good day, everyone. We are the Group 10, and our topic is all about the Maritime Navigation Radar. Here are the members: Teatro of James R., Utuan Christian, Onabia Erlin May, and Varga Adonis. Intended learning outcomes. At the end of the session, the students shall be able to comprehend the history of maritime navigation radar. Second is to determine why radar is such a valuable tool. And last is to recognize the ship parameters. History. New technologies of radar become available to merchant shipping with the end of hostilities in 1945. Radar on merchant ships was initially installed for commercial purposes. First is on ferries to maintain better schedules in fog, and second is for large fishing vessels. Radar was treated with great suspicion by the mariners. With improving technology, and after some time, the use of radar for safety purposes was recognized. Misinterpretation of radar information had not resulted in any reduction of the number of serious collisions at sea. International Conference on Safety of Life at Sea in 1960 revised the international regulations for preventing collisions at sea by adding rules to take account of the use of radar and recommendations on the use of radar information as an aid to avoiding collisions at sea. The International Conference on Safety of Life at Sea in 1974 adopted provisions to SOLAS Convention, making a radar mandatory carriage requirement for merchant ships in a phased program starting in 1980, which finally completed in 2002. So to continue the report, may I call on Decade Tutuan.
Thank you, Cadet Teatro. So, slide number 8, please, Cadet Teatro. So, SOLAS requirements. So, first, all merchant ships of 300 gross tonnage and over now shall carry a radar and many carry two. IMO adopted performance standards for marine radars, which are used in connection or integration with other navigational equipment required to carry on board ships, such as an automated target tracking aid, ARPA, AIS, ECDIS, GNS, and others. So, non-solo ships. Many small craft also carry radar voluntarily as manufacturers have produced cost-effective designs for their need. The shipmaster's point of view. The key facts are the radar remains and will remains the primary system for collision avoidance, and radar is a very important tool for navigation. Why is radar such a valuable tool? First, the master and watchkeepers have confidence in information radar provides because its operation in ship base. It's not reliant on third-party sources. It has a proven track record, and radar is useful with SARTs when engaged in search and rescue. In its display, radar offers the watchkeepers the basic reality of all targets related to the ship. It therefore aids the watchkeepers and help in decision making for both navigation aid and collision avoidance. In collision avoidance, early action is required to avoid a close quarter situation. Therefore, early identification of closing targets is essential. Watchkeeping officers need to be competent in the use of radar and trained in its use and application of ARPA. So to further more add information, let me call um, Decadit Unabia. Decadit Unabia.
So, Thank you, Decadet Utuhan. So some IMO requirements needs to have a maximum emergency stopping distance from full speed of the ship that should not be more than 15 ships in length, and emergency stopping distance should not be more than 2.5 ships in length. Next slide, please. So in shipping, the maximum speed would need to be up to 25 knots, and the length would be the largest container ship would be 335 meters. The capsize bulker is 300 meters, and the Panamax is 220 to 230 meters. And also the emergency stopping distance is 3.3 kilometers to 5 kilometers, and the emergency turning radius is 550 meters to 840 meters. And lastly, the displacement weights would be 100,000 to 250,000 tons. Next slide, please. So the practical requirements to start plotting targets and determining their course and speed with a target is between 8 and 10 nautical miles off. Next slide, please. So in navigation, the radar gives accurate information on the distance from the charted features and assists in maintaining the ship's course. So the radar will normally show a 60-meter high and landmass at a range of 20 miles. So this is considered by the seafarers as a minimum requirement. The radar greatly assists the navigation during poor visibility, and the pilots rely on radar at close range and reduced visibility to pass buoys and beacons. Next slide. So this is the table where you can see the MSC 192. Next slide, please. And here we can see our radar. Next slide. So discrimination of targets from a watchkeeper's perspective. So you need to be able to distinguish a tug from its tow at sea at 12 miles range. And also approaching a rig on a supply vessel to clearly identify the standby boat from the rig at 6 miles range, and to be able to distinguish the anchor pennant buoys of a semi-submersible rig at 3 miles range. So this is what I mean. So the next presenter would be Decadet Varga.
All right. Thank you so much, Cadet Anavia. Okay, so to start, resolution MSC 197279 or 551 range. The radar system should be capable of displaying two-point rather targets on the same bearing, separated by 40 meters in range as two distinct objects. 5.5.2 bearing says the radar system should be capable of displaying two-point targets in the same range, separated by 2.5 degrees in bearing as two distinct objects. Next slide, please. And 5.4 minimum range says with own ship at zero speed and antenna height of 15 meters above the sea level and in calm conditions, the navigational buoy in Table 2 should be detected at a minimum horizontal range of 40 meters from the antenna position and up to a range of 1 nautical mile without changing the setting of control functions other than the range scale selector. Slide, please. In engineering terms, resolution ITU-R M.1313 power 30 to 70 kilowatt hours, horizontal beam width of 0.5 to 4 degrees, a pulse with 0.03 to 1.2 microseconds, PRF of 4000 to 375 Hz, and noise figure to 3.3 to 8 decibels. Next slide, please. Antennae, the pitch should be 3 degrees, the roll should be 25 degrees, the yaw should be 5 degrees, and so the vertical beam width should be 20 to 30 degrees. Okay, here we can see an example of an X-ray band radar and a spiral band radar. And shown on the chart is waypoint 8B report on November 3. Here we can see some of the activities that are being shown in the graph. As you can see. Next slide, please. And here is the radar recording of the said voyage. You can see the targets and its particular positions on the radar. And here are the equipments or the radar example that are being used on board ship that is necessary when you are going to aboard the ship. To slide, please. And that's it. Thank you for listening, and we hope that you learned something.